What the is that? No, I'm not teaching you relational algebra. It's just not happening. But I guess I'm going to be talking about it, so here we go. What is relational algebra? When you write or execute a query in SQL, relational algebra is employed as part of the relational model. So what is the relational model, and what does algebra have to do with it? A data model is the formal specification for how the system represents and reasons about data. There were several data models before the relational model, including hierarchical and network models, both of which were popular but were lacking in data independence, meaning you were responsible for the connections, or links, between your data, which left a lot of room for human error. When the relational model was proposed by Edgar Codd in 1970, there were two key innovations. The first was a declarative framework, which applications used to specify the objects to be stored, the relationships between various types of objects, and all accesses to those objects. The second was a formal system for specifying data and operations on that data that allows both the user and the database engine to reason about correctness and to manipulate queries mechanically. The first point gives the database data independence, rather than requiring the user to manage the connections between data. The database can now ensure the relationships between data is stored and updated properly. The second point allows the database to apply optimizations to operations requested by applications. Like John was saying, we don't care how the database gets its data as long as it gets it. Ryan Johnson has a paper that describes this topic thoroughly and is my primary source for this video. So I highly encourage you to check it out if you're watching this, as it will go into a bit more detail. In his paper, he writes more about how the database optimizes these operations. These optimizations can include mechanically rewriting the query to access the underlying data more efficiently, select algorithms that perform less work, often by several orders of magnitude, and taking into account available resources, such as available memory and parallelism. The next section introduces this formal model, which is known as relational algebra. So now that we understand what a relational model is, it should be easy enough to understand that relational algebra is the formal algebra for manipulating data in the data model. In other words, every query that you write is an expression or a formula of the relational algebra. Relational algebra is still structured like algebra. Like multiplication, division, and operators, there are some new definitions you'll have to learn. You'll need to know what a set is, a type value, a Cartesian product, a relation, a generalized product, a relational model version of a relation, a tuple, and it goes on and on. There's also operators. And no, these aren't your typical plus and equals, divide and multiply. No. In relational algebra, we have, you might be thinking, wait a minute, I know that one. That's pi. Wrong. This is the operator for projection. Do you see what I mean? We also have selection, rename, natural join, join and equijoin, semijoin, antijoin, division, but not how you think division, left outer join, and of course the right outer join, a full outer join, and union. And then there's stuff like aggregation and transitive closure, whatever that is. So you see it starts getting complicated. So the big question is, why do you need to know this? The answer is, you may not need to. But that's a challenge in and of itself as to how far you're willing to go. Many people have worked with databases for years and have never used relational algebra. In class, we find ourselves using some pretty simple queries. While Full Sail prides itself on real-world education, the real world isn't so simple, in which case you may find yourself needing a grasp on relational algebra in order to create advanced queries with a mix of inner and outer joins, unions or subqueries, or generally anything that will give you anomalies. You can end up with duplicate data, missing data, or incoherent data without leveraging or understanding the relational algebraic basis of SQL. In short, relational algebra is a convenient basis for query optimization. By knowing relational algebra, you will successfully be able to comprehend, explain, and overcome these potential real-world problems. Thankfully, at least, we don't have to worry about things like relational geometry, or trigonometry, or calculus.